Happy day, YouTube. My name is John, and this is my channel, The Intermancer. I want to talk to you about some things that I've been doing. If you've been watching my channel, you know that I have been exploring the use of generative AI in coding as I work on my genetic AI system called Gaia F. In this episode, episode 5, I want to go over some refactoring that I have worked with. And it's interesting because of the conversation I had with Claude. I'm getting better at organizing my context and the conversation to get the code that I'm looking for. But I'm still having some problems. I still have some things to learn. And I think you'll see what I'm talking about. Well, I'll tell you what I'm talking about. I hope you see it. Before I have started with the code. This time I want to start with the conversation. And I've got it here on the Claude site so that we can look at the whole conversation. I'm going to go through the whole thing because there's some very interesting things in here. And then we'll hop over the code at the end. One of the things I tried to do here was to keep talking to the AI until it gave me all of the code I wanted. Spoiler alert, we never quite got there. But we got some good things out of it. So let's start here. First, I wanted to tell Claude that you are a professional Java developer. I have updated organism domain objects.md and basic arithmetic genes. The updates were included to the project knowledge. Compare the new versions of those files to the versions in GitHub. Then go through the code to identify what Java classes need to be changed. Let's look at the projects real fast, even though we looked at this before. You can see here with the GitHub integration that I'm including my GenAI context files from the project and all of the source code and the build file. So context, source code, and build file. And then separately, I added organism domain objects and basic arithmetic genes that had been updated. As I said in the chat, I wanted to compare the old version of those files to the new version and come up with all of the changes that it needed to make before it told me what those changes were and why it was making those changes. So Claude says, sure, I'll analyze the differences. It tells me it's going to do what I asked it to do and identifies various changes that it needs to make to the gene class and other minor additions. One thing, though, is that the new context files do not mention base single data point gene, nor do they implement the get index, or here, I'll pop over to that. You can see here that base single data point gene had a few convenience methods like index, because the normal gene deals with an array of indexes for how it pulls data out of the data quantum as it gets fed into the organism. And it has an applied constant that might be necessary. I realized that I was already providing some unnecessary features because I realized I didn't need any kind of applied constant for the sign gene as an example, and I figured that I would definitely be adding other genes that didn't need that. So even in this approach here, where I tried to bring all of these single data point genes and give them the base class that had some convenience methods, I was already having some vestigial code. So I decided to take all of that out. So it says here, base single data point gene with index and applied constant properties, implementation of operations, telling me what I have, and it says, okay, here's what we need to change. Core changes. Gene, we need to add a bunch of stuff. And base single data point gene, need to refactor to align with new gene interface. Need to refactor to align with new gene interface. You'll see that gene isn't an interface, it's an abstract class. That's something I've noticed during my time of working with AIs, doing Java programming, that sometimes it loses track of where it needs an abstract class versus an interface. If you're not a Java developer, that might be a distinction without value. But if you are a Java developer, you understand why it's important to keep clear the difference between abstract classes and interfaces. And way up at the top, I told Claude that you are a professional Java developer. So it should know that difference. It doesn't. So, details, talks about all these implementation changes. Oop, look at that. Base single data point gene. There that is. Keeps the index. Points it back up to this target index list. So I knew that genes would have a variable number of indexes that they needed to pull from. So instead of re-implementing that index list in all of the various subclasses of gene, I decided that that was a good candidate to pull up into gene, my base gene. Blah-de-blah, keeps on going. Implementation strategy, create a transitional approach in base single data point gene to maintain backward compatibility. I want to highlight that because that's a good idea. It's often a good idea to do things to maintain backward compatibility. Thing is, I wasn't really interested in maintaining that right now. And the first time I saw this, I was so focused on the code changes and the fact that base single data point gene was still here that I missed this comment, that it was looking for a transitional approach. Or else I would have told it, you don't have to worry about transitional approaches. We'll bump the major version if we have to, or something to indicate that this system is not necessarily backwards compatible with what came before. And it's still in development, so I don't care. But I didn't say that. All I said was base single data point gene is no longer part of the system. Okay. Further changes, revised implementation, update gene, refactor all existing base operation genes to directly extend gene instead of base single data point gene, and update all the tests. It didn't tell me delete base single data point gene, which is fine. I'm a Java professional and I told it I don't want it, so it didn't have to give me that direction. You'll notice, however, that applied constant still exists, and index, a get, still exists as properties, and it has now added these properties to each of the subclasses of gene, which is a big part of what I didn't want. I want these simple subclasses of gene to be very simple. So it goes through the code, it tells me the test updates, and that is what I told it. I tried to tell it None of the concrete genes should initialize target index list. I want the default of target index list to always be -1, which means that the default is that any gene is operating on the last data channel in data quantum. So it defaults to just whatever the last one is. And I want that to be the strongly preferred default behavior. So get rid of, I'll just read it, sorry. None of the concrete genes needs the set applied constant or get applied constant methods. None of the, I wanted those to stay inside of that base gene class. None of the concrete genes needs to test the length of values in the operation method. Similarly, none of the concrete genes needs to override get ID or toString. So see, there's a whole bunch of stuff that it was adding inside of, we'll look at sign gene, right? Set index, it's got that. During its initialization, it's adding a 0 to the index list. It's initializing that to 0, and it does that for all of these others as well. Add 0, adds a 1.5. It got the 1.5 right, but it keeps adding 0 when I clearly want the -1. So it says, thank you. I'll revise the implementation. It tells me what I need to do. Boom, boom, boom. All of this stuff. Then I get down to the addition, subtraction, division. It's giving me a lot of good information. Updates to make the test work. I read it all. I was pretty pleased with it. I say, the requirement stated that the genes that need an operational constant should initialize it with a value of 1.5. That should be included, and the test code should not need to initialize either the target index list nor the operation constant list. Update addition gene, subtraction gene, multiplication gene, and division gene to include the initialization of the operation constant list during construction. Modify the example test so that it does not adjust either of these properties. That's what's going on here and here. And you can see everything's pretty clean at this point. All of that extra code has been taken away. Division works. Still tests for constant, for division by 0. And it updates the test. But then we got to gene, and it says, since we will still need to be able to adjust the index and constant values for testing, we'll need to add these setters to gene or to each concrete gene class. Here's how they might look in gene. So clearly the AI is telling me, I get that you don't want to put these methods somewhere, but they need to exist. And I keep telling them, it doesn't need to exist. So I say very close. There's no need to create the index or the applied constant properties. And I just wanted to back down. But it didn't. It couldn't. And it just gave me the set for those. And I just wanted those properties to completely go away. At this point, however, the addition gene and the sign gene are very clean, and I'm happy with them. And it gives me an example of the test. Last thing I needed was to update test genes to take into account the changes to gene. It has all of these getting the target index list and operational content stuff inside the test genes class. And I still really, especially this target index list stuff, I really didn't want it. But I kind of gave up at that point. Kind of gave up at trying to get the AI to give me what I wanted. You can see here in the code that when I brought test genes over, I just didn't copy over those properties, that part of the code. You can see I haven't gone back to the latest version of the code. Let me check this out. Switch to commit. Okay, now I've gotten rid of BaseSinglePointGene, and you can see now that my gene class is a lot bigger than it used to be, but I haven't replaced the index or operational constant properties. I still have target index list and operation constant list, and I expect to work with those list properties even when I am dealing with single data point genes. For example, here with the addition gene, I want to initialize that constant value on a per concrete gene basis. So I have that, but nothing about the indexes. Now, the abstract class gene itself does have an implementation for target index list that initializes it to -1. Sometime soon I'm going to have to add a property to all those subclasses that tells it how big that array is, so that in this superclass I can loop through that known property and set and initialize that array to like -1, -2, -3, and so forth. So that's what it's doing. You can see that the Gradle build works just fine, and all of the tests pass, and God is in his heaven, and all is right with the world. Next episode, I'm going to try to really do some of this coding live, in the sense that I'm going to try to record and share all of my experiences working with the AI as I'm doing so. Hopefully I remember to think out loud. That's been the biggest problem I've had with that in the past. We'll see how it goes. Thank you for your time. I hope you found this interesting.